Hi everyone. Thank you for joining us again today. It's good to see that so many of you joined back. And in case someone missed yesterday's session, we have it recorded on our YouTube, so you can go and check it out. And yeah, Akshay is here with us, so Akshay, you can start.
Yeah. Let's wait. I think 2 or 3 more minutes. We'll see if someone else joins. So, how is everyone doing? I don't see any responses.
How many of you attended yesterday's session? Just drop a yes in the chat box.
Hmm.
Okay, awesome.
Hmm. All right. I think we can start. Hmm. So, for today, I will be covering data structures, and in data structures, we'll only be doing three very basic data structures. First is arrays, then queues, and stacks. So now I'm gonna give you a really clear explanation on what all three of them are, and also I'll be showing you the implementation. If there is enough time, we can go into problems as well. So from the crowd, would anyone want to answer what is a data structure?
Even a generic definition would do. So if you
Yeah.
have any idea of what is a data structure, just drop it in the chat box, or you can also unmute and speak or raise your hands.
Is there a raise hand feature on me?
Yeah, there is for attendees. Yeah.
Oh, is it?
Uh,
I didn't know that. All right. Hmm. So it's something that we use for storing data type of variable. So how is it different from a regular variable? I'll wait another minute and then I'll answer. Anybody? Hmm. Yeah, we can store multiple values. That's one point of a data structure. So a data structure means a particular way to organize data. So you have multiple data values and you're gonna organize them in a particular way and create a relationship between the data so that you can, yes, store and access the data efficiently. The chat is partly right. So so now so just note down. So if you want to think of a data structure, it is a way in which you organize data to store and access them efficiently. And the point of a data structure is to store multiple values and have a relationship between them. So as a rookie programmer, one thing that I thought in multiple scenarios was, can I dynamically create a variable in my program? So that is a really programming languages are not meant so that they can create variables dynamically within themselves. Has anyone else tried that, to dynamically create a variable in your program? Anybody? So this is one thing that all rookie programmers think of. So what you do instead of trying to create dynamic variables based on the data is you create a proper data structure and use it. So a good example of this would be, say, a collection of students. Now you write a program that has a collection of students. You can just create an array of dynamic variable. Oh, that's just an idea that I had as a rookie programmer. Say I have, you know, in my program, I'm going to get a variable value for which I'm not prepared. So in this box, one second, can you see my jam? So this box is our program. We're going to get in a value that we're not prepared for which we haven't assigned a variable. So based on this value, can you create a variable? Can you create a variable like that? It's really not possible in programming languages for you to create variables on the fly. You never write that variable's name in your program, but it should be created. That does not happen. So whenever you're not prepared for data, like say for example, a class may have 40 students, and now this teacher creates a program that has each of the 40 students in a variable. So you have 40 variables. You have 40 variables. So now a new student is joining the class. So each and every single time the teacher is going to go back to the program and then create a new variable, a 41st variable for the new student. That is really bad practice, and it's just not feasible. For every single data and entry, people cannot come in and create variables, and the programming language itself cannot create any variables like that. So you're going to be using data structures. So the same example of a class with 40 students. Yeah, if you have any doubts, someone unmuted. No doubts. All right. So I'll go with another example. uh, the same example where you have 40 students in a class and a new person is joining. If the teacher had something like an array, and this array can be an array without any fixed size. So that is possible to have an array without any fixed size. It can keep increasing. It's possible with Java collections, but I will not be going into that. But just know that it's possible. So currently you have 40 students, up to 40. Uh, but the size is not fixed. So let's say 40 is somewhere around here, and you have n here and you have 0 here. So when a 41st student comes, the teacher just adds the value here into the same array. So this array is accessed by a variable, say s for students. So the same student array is going to be accessed every single time. Just a new value has been added. So if a student leaves, you can just remove this data from there. So doesn't this make programming a little more dynamic and simple? So instead of creating n number of variables and treating those variables as students, having a student array, a collection of every single student, so adding and removing makes it, it's simpler and it's more intuitive like this, right? Does everyone agree? Yeah. So if So what is an array? I'll get to this question in just a second. We are going to be discussing arrays first. So an array, um, first things an array. What is an array? An array is a set of continuous memory locations. Sure. So a set of continuous memory locations that can store the same type of data into them, and they have a fixed size. So they have a fixed size, and they are all accessed by a single variable name, say s in our case. So an array is a set of continuous memory locations that can store the same data type accessed by a single variable name, and it is of a fixed size. And now How are these individual memory locations accessed? They are accessed with indexes, say 0, 1, 2, up to n minus 1 for an array of size n. So now an index starts from 0 and it goes to n minus 1. And if you say, if you want to access this array's second index, I'm going to be accessing this value. So now you asked me about a dynamic array, right? So does this really sound efficient for real programming practices, having a fixed size for an array? Aditi, does this sound practical? Hmm. So since it is not practical in Java, what they've done is they've created another class of arrays called lists. So what these do is whenever the size is full, when you try to add another element, right, it's going to increase the size of the array. So it cannot actually increase the size of the array, but what it's going to do is it's going to create a new array of a larger size, and it's going to transfer these values into it. So that is how a dynamic array is implemented. Did you get it? So when the array size is full, it's just going to create a bigger array, and then it's going to store this data into that. Did you get it? So arrays. Is everyone fine with the definition of an array? An array is a data structure that is made of continuous memory locations, and it has a fixed size. It can store the same data type, and each memory location is accessed with its index. So let's think of what we can do on arrays. You can do a lot of operations on arrays. Like one, you can do uh, first thing you can do is traversal. I'm doing this on my phone, so it's really the handwriting is going to be bad. So I'm just going to use T for traversal. Traversal basically means here you can see this array, right? Traversal means visiting every single element, every single location once. You visit this one, then you visit this one, and this one, then this one, and then this one, this one, this one, this one. You visit every single location once. That is traversal. And the next one that we can do is searching. So you can search for a particular value in one of these. Say this value is 5. You can you know search for this value in this array and then return the index. So this is another operation that you can do. And the next one is sorting. So you can sort the data in an array in an ascending order or a descending order. If it's numeric or even if it's alphabetical, you can do it. And then you have operations like you know insertion. So insertion is you're basically gonna find an index in this array. Say in index 3, I just want to change the value. So I want to change the value of index 3 to something else, new value. I'm just gonna write n there for new value. So you can add another element, and the existing elements are gonna get pushed by one location. That is insertion. And the next one that we can do on arrays is deletion. So the next that we can do is deletion. So now how are we gonna delete? To delete, you're gonna actually just remove this element, and then you're gonna move every single element by this direction so that it gets deleted. So I'll be showing you the code for all of this, and I'll teach you the algorithms. But these are the 5 operations you can do on arrays, and this is the explanation of what an array is. So far, is everyone fine?
Yes.
All right. So first, let's just go into how to declare an array and how to pass values to an array. This is actually going to take quite a bit of time. So all of the programs, right, they're really long, and if you had to code all of this here, it would taken us at least 2 or 3 hours. So all of them I've already coded down for you guys, and I will explain all of this line by line, so you don't have to worry. So first, let's go for how to, declare and initialize an array. Okay, so that totally depends on your language. So for C++, how to declare an array is, you first say data type. I'll first give an example, then I'll give you the syntax. Say int arr brackets, and size I'll say 5 for now. So the syntax is data type and variable name and square brackets and size. So this is the syntax to declare an array in C. There are other ways that you can statically initialize, but I won't be going into that. As you learn, you can self learn on that. I'll just show you int a is equal to, you can statically give some values 1, 2, 5, 6, something like that. But that's not really something that you will be using in your DSA life. So I'm just gonna teach you how to make this proper declaration. The next one for Java is int five. So this is how you declare in Java. So the syntax is again data type in square brackets to say that it is an array. Then variable name and mm, new is a keyword that is used to instantiate objects. So you got to use that new keyword, and then again data type. The data type should be same, if not you will get errors. And then size. So this is how you do it for Java. Now declaring them is easy enough, but initializing is where it gets tricky for beginners, because say you had int a, how do you read this? You either did cin of a, or you used to do sc dot next int of a. You used to do this, right? How are you going to read an array? So I will show you that now, how to read an array. So you will need a loop to read an array. So let's just go with this C++ declaration. So what I'm going to do is I'm going to say this. How do I read this? So say I read this size dynamically, but for now I'll just use this size as 5. So I'm going to go with a for loop. You usually use for loops to read arrays. You can do it with a while, but for is more intuitive. So you go with a for loop, and you have this iteration variable I is equal to 0, I less than 5, and I plus plus, and now you just come here and you say array of the index I is equal to no, this is C plus plus, right? So it's Cn array. Um, so this is how you read an array. I'll explain it. So as I said, in indices, right? So memory locations are referenced with indexes. So now how are you gonna do this? So indices always go from 0 to size minus 1, size minus 1. So if you see, our for loop is also the same. We are going from 0 to less than 5. So it's going to iterate 0, 1, 2, 3, and 4. So 5 indexes are created, 0 to 4. And for each one, you're reading the value. So this is how you read an array. Is everyone fine with this? Is everyone fine with how to read an array? All right. So now we'll directly move into traversal. So traversal is also exactly the same. So instead of reading, you're just gonna do any other operation. For traversal, no. Traversal, you just make a for loop for every index, and I'll just do a C out. So you're traversing the entire array and you're displaying the output. Traversal is this easy. You just need to loop through every single element. So traversal is done. So searching and sorting we will not be covering in this session because I have a separate session for that. We'll go through all of the searching algorithms and sorting algorithms. But one thing that I will be touching on here is insertion and deletion. All right, everyone's fine with that. So first I'll show you how to insert and delete logically, and then we'll go through the code also. I'll show you. So give me a second. So now let's take a small array of size 6 perhaps. Two, 3, 4, 5, and 6. So you have an array of size 6 here. So how are the indexes going to go? 0, 1, 2, 3, 4, and 5. So now let's fill it till index 4. Let's say I'll do it like this: 1, 2, 4, and 5. So we've done till here. So now you can see, now say I want to put 3 in position 2, and then I want to move everything that side. So how are we going to do that? So logically, the way to do this, the algorithm, how it works is, first what we're going to do is we're going to go to the last position where the last element is. So that is this one. So what we're going to do is we're going to move this 5 to the next position. We're going to move 5 to here, and then this pointer comes here. So this is the index till where we have to move it. So this one moves here, 4, this becomes 4, and this is the place where we want to insert it, right? So here you're going to insert 3. So now you can see this has been inserted in position 2, everything else has been moved by 1, and you're going to update the size to 1, 2, 3, 4, 5. Size is 5 now. So you're going to go till here. So this is how you do an insertion. You're going to start with the last element. You're going to move it towards your right by 1. That means you're going to increase its index by 1 until you reach the position where you want to insert it. Then you're going to put the new value over there. So this is how we insert. I'll show you the code for this, but is everyone fine with the logic? All right. Uh, oh yeah, the last position we haven't really added anything in it, right? So the size of the array is still 6, but I'm saying the size of the number of elements. Okay, it's confusing. I'll call this number of elements. I'll change the value of number of elements to 5. The size of the array remains constant, but the number of elements, I'm just using that to iterate, right? So the way this is written is, I'll show it to you when we go through the code. uh, I'll just do deletion first and then I'll show you guys the code. All right. So now deletion. Again, I'll have an array. So I have 1, 2, 3, 4, and 5. So the size is, like, 1 second. So the size is 5. So say I have 1, 2, 3, 4, 5, and I'll have the size as 6 just to iterate on the point that I made. But the number of elements is 5, right? So this is what I wanted to do last time. So again, I have my indexes 0, 1, 2, 3, 4, and 5. So say I want to remove this index 2, this 3, I want to delete it. So what I'm going to do is I'm going to start from the index after 2, which is 3. I'm going to go to this index 3 and I'm going to shift this value to the left. I'm going to make this value as 4, and then this point is going to move here. Now I'm going to come to 5 and I'm going to move 5 here. So when I am at my index of the 5th element, that means index is going to be 4 here. So when I come here, I'm going to replace this with say 0, or you're going to just make it empty, you're going to make it null. So you're going to make this null. So this is how you delete. You're going to start with the element after the element you want to delete, and you're going to shift everything left. So is everyone fine with the logic for this? All right. So now let's go into the code. So I have separate, this is for insertion, that's all right. So I'll show you guys, I'll walk you through the code line by line. So here I am creating my scanner variable, and here I am just outputting saying enter the number of elements you want in the array, and I'm giving the input as 5. So n is going to be 5. So now I am creating a new array of size n plus 1 because I need one extra position, right? Because I'm inserting one element in, I need one extra position. I'm not using that Java collections array, so it's not dynamic. Since it is a fixed size, I'm showing you code just to insert one element. So one more thing what you could do is, you can, why don't you take this as an assignment? Try to create this same program, but that can insert up to 5 or 10 elements, new elements. It should be able to insert 5 to 10 new elements. Try to do this as your assignment, but for now I'll show you just one. So because I need one extra element that is going to be inserted, the size is n plus 1. So now I'm going to read n elements. So in our case, 5 elements. So here it is 1, 2, 4, 5, and 6. It's going to be read and it's going to be stored here into the array. So now I'm saying at which position I want the element to be inserted. I'm saying position 3. Just keep an eye on this. I'm saying position 3, not index 3. So I'll tell you about that. So if you say position, this is at position 1, this is at position 2, 3, 4, and 5. But index wise, this is at index 0, this is at index 1, this is at index 2, 3, and 4. Just keep that distinction in mind. So now I'm checking the element that has to be inserted in this position. So that element is again 3, the element that I'm going to be inserting. So now as per our logic, right? So we start with the last position. I is equal to n minus 1. So wait, let me go to our Jamboard. So where is my insertion? It was here. No, this is my, yeah, this is my insertion. So the before it was only till here, right? So this is my n minus 1th index. So I'm starting from this position. All right. So what am I doing here? So I'm starting from that position and I'm going up to position minus 1. Why are we doing position minus 1? Because we took position and not index. So our position is 3. So the index is here. This is at position 3. But the index of this is 2, right? So that is why it is minus 1. Position minus 1, and we are decrementing. So usually we've only seen for loops that we're having plus plus in my class till now. So this is minus minus. So if you just think of for loop that has plus plus to move towards the greater one, minus minus just moves from it moves backwards. So what we're going to do is, now you're saying a of I plus 1 is equal to a of I. So in our Jamboard, if you see, this is our first I, right? So this is I plus 1. So you're saying I plus 1's value is equal to the value of I. Is everyone able to see my mouse pointer, or should I use the Jamboard for this? That is too much work. I'll just use my pen. You know. So here, so this is my current I, and this is my I plus 1, and this is my current I. So I'm transferring this value to this location. I'm copying it, not transferring it. So I'm going to do this until, so once this is done, my I is going to shift to here, and this is going to be my I plus 1. Then I'm moving this value here. So now if you see the condition, it now my I is going to come here, but it does not satisfy this condition. So it comes out of this loop. And now I'm saying a of position minus 1. So our a of position minus 1 is the index where we want to store our value. And you're just going to store the new value here. And after that, I've just written some code to display the output. You can see I have a for loop that goes from 0 to n, not n minus 1, because we have a new element added. So it goes from 0 to n. And then we just display this. So I'll just show you guys for another, I'll say 6 elements this time. And the elements are 1, 2, 3, 5, 6, 7. And now I want to enter, I want to enter 4 in position 4. So position is, no, wait. Say I enter 10 in position 4. That way you'll be able to see how it works. So now I'm going to say position 4 and 10. And when I run this, what happened? Enter all the elements. Did I miss anything? So, oh, yeah, I missed spaces. All right. See, in position 4, 10 has been inserted. Is everyone fine with the explanation that I did in the diagram and the code? If you have any doubts in the code or in the diagram, you can ask me now. Okay, nobody answered. So, all right then. So I'll assume there are no doubts, and I'll move ahead. If anyone has any doubts, you can reach out later on. So next is deletion. I'll share the code for deletion. Yeah. So first I'll just run through my code really quick. Again, see here, I'm asking for the elements and I'm reading the elements of the array. Here I have not done n plus 1 because I'm deleting. I'm not adding anything to the array, so a size n is sufficient. I have created an array. I have read the values. And now to delete. So what I'm doing is I'm also doing a search operation here. So I'll tell you about that. So here what I'm doing is I'm saying enter the element you want to delete. So and I'm reading a value. I'm not reading a position. So what I'm going to do is quickly I'm just going to traverse through this array. So what I'm doing here is I'm going from 0 to the last element and I'm checking if the value at that position is equal to the element that I want to delete. If it is the same, I am going to have this flag variable set to 1. You can see flag is set to 1. Yeah. Okay. If it is matching, I'm setting it to 1. I am storing the location of this, that is the index I in this location variable, and I am breaking out of this for loop. So I'm not going to iterate anymore. I'm just going to come out of this code and I'm going to jump to this line, that is break. So if it is not matching, I'm setting flag to 0, saying I did not find any match. So it's going to say for this example 3, right? It's going to go here. 1 is 1 matching with 3. It is not matching. It's going to go into this else. Flag is set to 0. Then it's going to increase this. And then we're going to come to 2. 2 is not equal to 3. Again, we're going to go here. Flag is set to 0. But 3 and 3 are matching. So then we come here. Flag is set to 1. Location is set to 2 because the index of this position is 2. And then we are breaking out of this for loop. And we're coming to this if statement. If flag is equal to 1. So if flag is 1, that means the element exists. And what we're doing is we are, doing the logic. I'll tell you this logic now. If you can see our Jamboard for deletion. So we wanted to delete this one, right? So we started with the element that is next to it. 1 second, let me just okay, all right. So to delete this element, you start with this position as I. So what we're doing here is so you're saying you're going to the position after that, and what you're saying is I minus 1 is equal to I. So what we're doing is I minus 1 is this one. This is I minus 1. So I minus 1 takes this value and then I increments to the next element. So this becomes I minus 1. This value is transferred here. So this goes on until you have elements in the array. And then what happens at the end here, you can see after deleting, we're just displaying it. So this is the logic for deletion. And I'm just saying, so this is if flag is set to 1 and the element exists. So if the element does not exist, what we're doing is we're saying element not found. And while displaying, you see here we're doing n minus 2 because we have deleted one element, right? Oh, this code was kind of unnecessary. This is plenty. All right. So now I'll just show you the same example. So here again 5 elements, 1, 2, 3, 4, 5, and I want to delete the third element. And the third element has been deleted. So this is the code and this is the explanation for how the code works. Is everyone fine with arrays, insertion and deletion? I need some responses, guys. If not, we can move really quickly. The faster you say yes, I'm gonna switch to the next topic. All right. So the next one. Now we're gonna do stacks. So let me just Google a picture of stack. Um, yeah, so this should work. So a stack is basically an array, but the way you're gonna use this array is different. All right. So it's basically an array, but the way you're gonna use it is different. You're not gonna be using indexes to access the elements, but you're gonna use this concept called top. Just give me a second. Let me get a sip of water. So in a stack, you're not going to be accessing any value by random. You're only going to access the most recent value. So, you know, a stack is a LIFO data structure. So, last in, first out. So what that means is the element that has been pushed into the stack last is going to be the one that is going to be accessed first. So this is really helpful to solve certain kinds of problems. I'll even tell you what kind of problems these solve. So what you're going to do is you're pushing one element. See here, one is pushed, then two is pushed, three is pushed. So when you want to access elements from the stack, the only element you're going to be accessing is three. So after you delete three, you're going to be able to access two. After you delete two, you're going to be able to access one. Is this clear? Guys, chop, time's running out. All right. So that is how we're going to access a stack. So I'll just show you something that you really need to know when you're developing a stack. So think of this as a stack. I'll do 1, 2, 3, and 4 elements. So now you're going to have something called top. So this top variable is used to access locations in the stack. And when the stack is empty, you're going to set top to -1 because there are no elements. Top is not pointing to anything and it is set to -1. So if your top is -1, that means your stack is empty. Empty. So now I'm going to, when pushing, what I'm going to do is I'm just going to say plus top. You guys know what is plus, right? It is pre-increment. Before accessing the value of top, we are adding 1 to top. So -1 plus 1 is going to be 0. So at 0th location, you're going to add a value, say 2. So when I'm adding 3, I'm doing plus top again. So I'm going to be, having 3 here, and top is going to be, it was 0 before, now it is 1. So when top is equal to size -1, say this is S, okay? When top is pointing to size, just a second. Yeah, when top is pointing to size -1, that means top is already here. You cannot move it further. So stack is full. If the top is -1, it is empty. If it is size -1, it is full. So whenever you're deleting, what you're going to do, you're going to access top's value, you're going to return top value, and you're going to do top as minus. So top is going to be reduced by 1. So that means whenever top is again equal to -1, you cannot reduce it further. because there are no more elements in the stack. So if top is equal to size minus 1, you cannot add anymore. If top is equal to minus 1, you cannot uh, delete anymore. So this is the explanation for stack. Is everyone fine with that? All right. So everyone's good. Let's move to stack. This is a circular queue, and this is queue, and this is stack. All right. First, I'll show you guys my code. I've used functions. I haven't explained what functions are, right? So a function is basically just this name given to a set of uh, lines, and I'm also passing certain values so that these values are going to be used here, and this sometimes returns another value. So here, as you can see, where I'm calling it, right? So display. So whenever I say display, this display function, this part of the code runs. So instead of writing this code 10 times, I can just write display 10 times and get done with it. So sometimes this returns a value. So if that returns a value, so this display is going to be replaced by a value. So I think we'll touch that on later classes, but I think that's, you know, enough explanation for this one. And have I used that one here? Let me just run this. Yeah, so I've used a menu driven program here. So I'm using a while loop and I'm getting choices. So whenever I enter 1, it is going to push an element into the stack. Whenever I'm entering 2, it is going to remove an element from the stack. 3 is going to display all of the elements in the stack, and 4 is going to exit this. So this loop is going to run until and unless I press 4. So this is a menu driven program. So I'll give this as one of the assignment. You people also can make a menu driven program. So here what I'm doing is I'm just using this do while loop to show this menu, and each time I'm getting a response, I'm gonna execute one of this. So say 1, I'm saying push element into stack. I'm saying enter the value to be pushed. So say 10, and now it has been pushed. I'll show you that it has been pushed by displaying the stack. So elements are so far 10. So I'll show you how it has been pushed. So in our code, as I explained, top has to be -1 since you're starting empty. The stack size, maximum size I've given as 100, and this is n. I'll change these to 5. All right. I'll change this to 5 so that I can show you guys that it got full and when it gets empty. 5 is also too much. I'll go with 3. Okay, I'm going with 3. So now the stack size is 3, so it can hold up to 3 elements. So when I come here, first I'm checking, is top greater than or equal to n minus 1? Didn't I explain the same condition to you guys here? If top is equal to size -1, it cannot take any more elements. So the same thing I've written down in the form of code. Is top greater than or equal to n minus 1? Then cout stack overflow. This is just a term to say that the stack is full and you cannot add anything else. So if this is not the case, that means it can still take more values. So I'm saying top plus plus, we are just increasing the value of top. So it was -1, now it becomes 1, and I'm at it becomes 0. So at position 0, I am inserting this value 10. So that is how push works. Everyone's fine with push? All right. So everyone is fine with push. Let's see pop. So pop also, as I explained here, what we are doing, we are just making top's value go down by 1 and we're returning the value. So what we're gonna do is here. So if top is less than or equal to -1, we cannot delete anymore because -1 means the stack is empty. I already explained that in this diagram, didn't I? If it is -1, you cannot add anything else. So same way, first you're saying if it is less than or equal to -1, stack underflow, which is just terminology for stack is empty. So now I am displaying the element that has been deleted. So the element at the top is going to get deleted all the time, right? So I'm just saying stack at this index top I'm displaying, and I'm doing top minus minus. I'm reducing the value of top to point at the one below that. And to display it, we used to display arrays from index 0 to n, right? But in stacks, you're going to display in the reverse order. You're just going to, the logic is pretty simple. See, if top is greater than or equal to 0, that means if the stack has any values, then do this, else stack is empty. So the elements are, and here I'm just saying I is equal to top, I greater than or equal to 0, I minus minus. I am moving down like this. I is equal to top, and I'm gonna come down, and I should be greater than or equal to 0. And what am I doing? I'm just printing the value, and I am done. So this is the program for stacks. It's pretty easy, but I'll show you the working now. So one, I'm gonna enter 10, and again I'm gonna do 1, I'm gonna enter 20, and now I'm gonna delete. Okay, so as you can see, the second option is for deleting, pop from stack. So in arrays, we had to specifically ask the user, bro, which element do you want to delete? But here you're not gonna ask. Say I'm gonna delete, it says 20 has been deleted because 20 was at the top. So now I'm gonna display it once. And it says elements are only 10 because 20 was deleted. Now what I'm going to do is, again, I'm gonna insert, say 30. I'm gonna insert, say 40. Now I'm gonna try to insert another one, which is gonna be 50. Stack overflow, because our stack can only hold 3 values. Now the top is going to be at 2, so it cannot go over 2. So it's saying stack overflow. So now I'm going to start deleting. Wait, what if is my keyboard not working? Hello, am I still audible? It's my net.
Yeah, you're audible.
I think something's wrong with the website. Just let me type. Yeah, my keyboard's working. The website's a little buggy, but I trust that everyone has understood this code. Is everyone fine with this code? Any doubts with the implementation? Any line of code that is not unclear, you can ask me now. Guys, any doubts? All right. Yeah, something's really wrong with this program. Okay, yeah, it's working again. I'll just do it really quickly. Okay, I'll try to delete when there are no elements. See what happens. Stack underflow. That's what I wanted to show you guys last time. So that's done. I'll exit. One more assignment is I wanted people to do a menu-driven program for insertion and deletion. I showed you insertion and deletion, right? I want you to combine both of these into a single program and use a menu-driven approach like I have done. If you want, I'll give you this code for reference. Use this and create your own menu-driven program, and don't spend too much time on it. Work on CodeChef mostly. So the next one that I wanted to touch was Q. I'll try to. It's already 8. I'll try to cover it up in another 10 minutes. Is everyone fine waiting another 10 minutes? All right. I hope you guys are not getting bored and sleepy, right? Hmm. All right. So we'll quickly do queues. The standard implementation of queues is very flawed for one reason. I will tell you that. Say I have a queue of size 2, 3, and 4. So a queue is a FIFO data structure. So it can take like first in, first out. So where we had top first stack, we're gonna have two things. This is gonna be called front, and this is gonna be called rear. So whenever an element is inserted, it is inserted at the rear position. Whenever an element is deleted, it is deleted from the first position. Say for example, a queue at a movie theater or a restaurant. See, you have a queue, the person at the front goes away, new people are coming at the back. So it's that it's very intuitive, it's literally the same. So now I'll tell you the problem with queues first. So now say I delete this, now our queue is of size 4 and it has 1, 2, 3, and 4. Now I am removing this person. So front is going to move to here. This is going to be my front. Can I add another person here? Because the person can only be added at the rear, right? And rear is already at the end of the array. You cannot add more people as you delete from a queue. You can only add n number of people, and as you delete, you will not be able to add more people. In stacks, we were able to delete and add. If it's full, delete the top one and add another one. But for a queue, that is not possible. That is one way, that is one implementation style of queue, and I'll show you how you can overcome this. But before that, first let's go into how a queue gets values. So same 4, let's take it, 2, 3, and 4. So initially front and rear are going to be -1. So I'll just say 0, 1, 2, and 3. So front and rear are going to be -1. So when the first element is added, rear is going to be, you're going to do rear plus plus. So it's going to become 0. And since one element has been added, you're going to send front to 0. Since one element was added, you're going to set front to 0. You're not doing front plus plus, mind you, you're doing front is equal to 0. So now I'm adding, say 1 was added and this happened. Now rear is 1, rear is 0, front is 0. Now I'm adding 2. What is going to happen? Rear is going to do rear plus plus, rear is going to be 1 now. R is 1, but front does not change. So now I'm adding 3. Rear becomes rear plus plus, that is 2. 3 has been added. Now say I'm adding 5. Now rear plus plus, rear is 3. So at this point, R is 3 and F is 1. 1 second. So F is 1. Oh, I'm really sorry. I was doing that here. Do you want me to repeat this? I was doing it on another. Do you guys want me to repeat this?
Yeah, if you could repeat once more.
Yeah, I'm really sorry. I messed up there. I'll show you in a new one again. So here you can see 2, 3, and 4. Indexes are 0, 1, 2, and 3. Now first my F is going to be -1. My R is also going to be -1 because the queue is empty. Now the first time I add an element, we're adding to rear, right? So rear plus plus. So rear becomes -1 plus 1, which is 0. But since you added the first element, you have to change F to 0. You're not doing F plus plus, you're doing F is equal to 0. Mind you, this is really important. F is equal to 0. So the next time you're going to add something, so I added 1. So now I want to add 2. So my rear here, it's 0 here. Now my rear plus 0 plus 1 is again, now it's going to be 1, and here I'm adding 2. I'm going to add 4 now. So rear plus it's going to be 2, and here I'm adding 4. Now rear plus it's going to be I'm going to add 5, it's going to be 3. Now we are at the end of the array. We cannot add anymore because rear is here right now and front is here. So this is inserting into a queue. This is how it works. Now for deletion, what we're going to do is you are simply going until and unless f is less than or equal to r, that is front is less than or equal to rear, because can front cross rear? Is it possible for front to cross rear? Guys, quick. Is it possible for front to cross rear? No. Front cannot cross rear because rear is at the last point at the queue, right? So until and unless front is less than or equal to rear, you're just going to move it here. So front moves here, this element is deleted. Front moves here, this element is deleted. So now we deleted 2 elements, right? Are we able to add a third element? We are not able to add a third element because the array has reached its end. So this is the implementation of a regular stack. Once full, you can never delete and add more elements. So you can delete it again and move here, and then you can delete it, and front and rear will point at the same. So now after deleting the last element, what you're going to do is you're going to set front again to -1 and rear to -1. If the last element is deleted, you're going to set front and rear to -1. So that is the implementation of a regular queue. Is everyone fine with this? I'll move on to the code. I'll get a sip of water until you guys reply. I know my handwriting sometimes gets really messy, but bear with it. Is this a circular? Okay, this one then. So let's run this real quick. Okay, this is also a menu driven program. I'm going to insert, it has size 10. I'm going to make it 3 again. I'm going to make it 3 so that we can get through it faster. See, you can see front and rear are set to -1. So I'm going to run this and I'm going to say 1, 2, enter an element, and I'm going to insert 10. Has been inserted. I'm just going to display it real quick. So 10 is inserted. So now I'll show you how we are inserting. This is the insert function. It's literally the same as the other program. It's a menu driven program. You can try it out yourself. So now we have int value. So value is the value that we're going to enter, which is 10. So now we are saying if rear is equal to n minus 1. So that is the same as what it was here. Rear is equal to n minus 1. So we cannot add any more elements. So what we're doing is we're saying queue overflow. If not, if front is equal to -1, that means the stack is empty. We are setting front to 0, and we're saying insert the element. Yeah, you're reading actually this. I've written it wrong. Element to be inserted in queue. It's not fetch. Fine. So again, 1, 10, and again. So see what happens. So I'm saying I'm reading the element to be inserted. Val 10 I have read it. So I'm doing rear ++, and in position rear, I am adding the value. Same as the explanation that I've done here, I'm doing the exact same thing. So now I'll show you how first I'll add every single element. Okay. So I'm going to do 1 again, and I'm going to insert 20. I'm going to do 1 again, and I'm going to insert 30, and I'm going to display the queue. See, unlike a stack which was printing in reverse, this is printing in the forward order because it's a FIFO data structure. I'll try to add 40, but it's not going to take in 40. Invalid. Oh, sorry, my choice was wrong. My choice should have been, oh yeah, it is right. Queue overflow. So what is it saying? Because rear was equal to n minus 1, it's saying queue overflow. So one more thing that we're going to do now here is let's delete now. See what happens. I deleted one element, so 10 has been deleted. So the first element. So see the logic for delete. If front is equal to minus 1, queue is empty, and front is greater than rear. As I said, front can never cross rear. So if it is either one of these, I'm saying queue underflow, which means queue is empty. If not, I'm saying the element deleted from the queue is whatever is in the front. I am showing this and I'm saying front plus plus. That is all it is for deleting. So now I'll delete it again. 20 gets deleted. So now I'll try to enter something again. Queue overflow. As I said, deleting does not mean you can enter again for normal implementations of queue. So now again I'll delete another one. 30 has been deleted. Now I'll try to delete again. Queue underflow. So is everyone fine with this explanation? The code, I will be giving you this code as well. So have you understood how queue works? So now, as I explained, I just want you people to give me a quick answer. What was the flaw in a queue? It was not a flaw, but what was one thing that we could not do with a queue? You can unmute and answer. Anyone? Nobody? Yeah, you cannot add as you delete in a queue. Perfect. So you cannot add more items as you delete. So how do you combat this thing? You make a circular queue. I'll just show you what a circular queue is real fast. All right. So a circular queue is the same as a queue, but you can think of it like this. 2, 3, 4. So 0, 1, 2, and 3. So say this is my front and this is my rear. Okay. So as I delete, my front moves here. Okay. This is going to be my new front, and rear can move here. So this is going to be my new rear. 0 will be my new rear. As I delete, so this will be my F and this will be my R. So there is no way for you to store data in a circular way in a computer, but you can simulate it. So did you people understand why you can add as you delete based on this diagram? Did you people understand why you can add as you delete in a circular queue? After the size, after the maximum size, if 0 is empty, you're just going to add to 0. You can envision it as a circle. Is everyone fine with the diagram? Please drop a yes if it is. See, same way as this. See, front is here, rear is here. You can add one here, you can add one here, you can add one here, it's full. This one gets deleted. Then the next one you're just going to add here, and front is going to be at this position. So is everyone fine with that? Okay, I'm glad you guys are fine with that. So we won't be needing to go into insertion and deletion again because you already know how it is done in a queue. You just need a simple modification to the old code, which I've done here using Java. So here you can see I have my size, I have my front, and I have my rear. And yeah, someone asked me about dynamic lists, right? So this is an array list from Java util. This can be used as a dynamic array. You can read into that more on your own, or if time permits, in our 3 weeks, I'll touch this. All right. So first, I'll show you the implementation. All right. So let's start with the main function as always. So I haven't done a menu driven program for this one. Uh, this is basically all Java syntax. I'm calling this from constructor circular queue with 5. Let's see what happens there. Here it is. So this function gets invoked. What happens here? You're gonna have size 5. I'm saying this dot size is equal to 5. That is this size, this object size, and I'm saying front and rear are equal to -1. So I've just set the values. Size is equal to 5, front and rear are -1. So now what I'm gonna do is, the only change comes when you're adding and deleting. So I'll show you this NQ. Yeah. So adding into a queue is called NQ, and deleting from a queue is called DQ. So adding to a stack is called push. Deleting from a stack is called pop. So first let's see this NQ function. This is DQ. Yeah. So NQ. So I'm getting data. The data is the value that has to be inserted at the position. And I'm saying if front is equal to 0 and rear is equal to size -1. So if front is equal to 0 and rear is equal to size -1, it means every single position is filled, correct? If front is 0 and rear is here, that means everything here is filled. Yes or no, guys? Really quick. Do you think it is filled? If front is equal to 0 and rear is equal to size -1? No answers? I'm not really going to move ahead until at least one of you answers. Come on. Is my network fine? Hello?
Yeah, it's fine. Guys, if you have a doubt or you're not able to understand, please let us know. We'll go over this again.
Hmm.
Anybody knows the answer? If you don't know the answer, please drop a no, then we'll explain it.
Or if this is too confusing, we can carry on in our next class. So should we go on with this in our next class, guys? Yes, no? Or do you want to continue now? Yes for continuing, or next
Yeah,
class?
I think it's a bit too
Okay.
much for beginners
Yeah.
right now.
All right. So is everyone fine till arrays, stacks, and normal queues? Is everyone fine? All right, then we'll do circular queues in our next class. Fine then. Nice talking to all of you. At least from my side, I was talking. Most of you didn't answer.
Okay, I request you all to please wait a few minutes before leaving. I just need to inform you guys. So yeah, talking about the assignments that Akshay gave us in the middle of the class, we will be sending you some links and some resources. I did say that we'll be sending it yesterday, but for some reasons we could not. Yeah, the recording as well. We'll be sending it to you by tomorrow. Actually, it's already available on YouTube. So just go to GDSC Kalindi ka YouTube channel. I'll type down the link for that. There it is. Like there is a separate playlist for the DSA Bootcamp. It's right there. You'll find it on the homepage of GDSC Kalindi YouTube. Yeah, just go to our YouTube. Both the sessions, today's session and yesterday's sessions, you can find there. And we were talking about some material related to courtship and assignments. Those we'll be sending them out to you all by tomorrow evening at max. And we will be having a doubt session on Wednesday with Akshay. So yeah, before that, I request you all to join our Discord because we'll be taking up doubts from there only. You just need to post your doubts in the DSA channel there. Yeah. So yeah, that's
And
huh.
yeah, please post the doubts by Tuesday night so that I can take up all the doubts I'm going to be covering on Wednesday. And not everyone is required to join. If there are people with doubts, they can join. I will not be teaching anything new on Wednesday.
I think your voice is breaking, Akshay.
Am I audible now?
Yeah, you're audible.
So I was saying, please post all your doubts by Tuesday, and I will be taking up doubts posted on Monday and Tuesday on Wednesday. And I will not be teaching any new topics, so people with doubts can join and others need not join.
Yeah. Also, one more thing. Can I just get a quick yes and no that do you guys want us to take an extra session on the syntax of Java and C++? If you guys say, then we'll take up a session for that. So just drop a yes or no. Do you need a brush up of Java and C++? Yes or no, guys? Okay, now I just want to know which one do you want first. I would suggest that let's go with Java first. C++, I think a lot of you have already done. So yeah, let me know. Java. What about others? Yeah, there are 38 people. What about the rest? So yeah, these sessions, not everyone has to join. Only people who have problems in understanding the syntax, or they forgot. Maybe you learned Java last year, or so. I understand that you must have forgotten. So I'll be taking a session on Java, and we will still be doing C++ next. Yeah, of course we'll be doing C++ as well. We have people in our team who will be taking up a similar session on C++ revision as well. So yeah, first we'll go with Java. So anybody here who has like done C++ and would like to join the Java session as well, you are welcome for that as well. And we'll be taking it up on Discord. So Akansha, can you share the Discord link once again? Please do join Discord. There, we'll inform you of the time and date very soon on your emails and on all our socials. So just keep an eye on your emails. And on Discord, we'll be taking up a session on Java in the next 2-3 days itself. Until then, please keep revising and do explore CodeChef. We will share links with you for CodeChef as well by tomorrow night. So, anything, anyone, or is it all cool? Like, how was today's session? Did you all like it? Guys, yes or no? You liked it? Was it informative? Like, yesterday we was totally into the basics, and today we were suddenly learning arrays, stacks, and queues. So, yeah, great. Good to know. So, all right then. Do keep checking your mails and do join our Discord. And thank you for coming, everyone, today. We will see you all on Wednesday or next week or in the Java session. So thank you, everyone. And thank you, Akshay, for the session today. It was really informative.
You're welcome.
All right. Bye, everyone. Thank you.